Our story begins about 4.5 billion years ago. Imagine a vast cloud of gas and dust, a nebula adrift in the cosmos. This cloud, a stellar nursery, held the building blocks of our solar system. Gravity, the architect of the universe, began to pull this material together. As the cloud collapsed, it began to spin faster and faster like a spinning top. The center became incredibly hot and dense, eventually igniting into a star, our very own sun. Around this newborn star, a swirling disk of leftover material remained. This swirling disk, a chaotic dance of dust and gas, held within it the seeds of our planet. Over millions of years, particles collided and stuck together, gradually growing larger. These growing clumps became planetesimals, the building blocks of planets. One of these planetesimals, destined to become our Earth, continued to attract more and more material. The early Earth was a hellish world, a molten ball of rock under constant bombardment from asteroids and comets. These impacts generated immense heat, keeping the planet in a molten state. As the bombardment subsided, Earth began to cool. Heavier elements like iron sank to the core, while lighter elements like silicon and oxygen formed the crust. Volcanoes erupted, spewing gases from the interior, creating a primordial atmosphere. But something remarkable was happening. Water trapped within the minerals of the accreting Earth was released through volcanic activity. As the Earth cooled further, this water vapor condensed, forming clouds and eventually rain. Oceans began to form, covering most of the Earth's surface. This water, the lifeblood of our planet, would play a crucial role in the emergence of life. The early oceans were a chemical soup, rich in organic molecules. Energy from the sun, lightning strikes, and geothermal vents provided the spark for life to begin. Exactly how this happened remains one of science's greatest mysteries. The first life forms were simple, single-celled organisms, likely resembling bacteria. These early pioneers thrived in the harsh conditions of the early Earth, evolving and diversifying over millions of years. One of the most significant events in Earth's history was the evolution of photosynthesis. Cyanobacteria, also known as blue-green algae, developed the ability to harness sunlight to produce energy, releasing oxygen as a byproduct. This oxygen, initially toxic to most life forms, gradually accumulated in the atmosphere. This great oxidation event transformed Earth's atmosphere, paving the way for more complex life to evolve. The Great Oxidation Event was a pivotal moment in Earth's history. The rise of oxygen had profound consequences for life on Earth. Oxygen is highly reactive, and its presence in the atmosphere led to the formation of an ozone layer. This ozone layer shielded the Earth's surface from harmful ultraviolet radiation from the sun. This protection allowed life to move out of the oceans and onto land. The continents, once barren rock, were slowly colonized by plants and animals. The increase in atmospheric oxygen also allowed for the evolution of aerobic respiration, a more efficient way for organisms to extract energy from their food. This paved the way for the evolution of larger, more complex life forms. Over billions of years, life on Earth flourished and diversified, evolving into the incredible array of plants and animals we see today. But this journey was not without its challenges. Section 5. Life's incredible journey. Life on Earth has faced numerous challenges throughout its history. Volcanic eruptions, asteroid impacts, and dramatic climate shifts have all threatened the very existence of life. Yet, life has proven to be remarkably resilient. One of the most well-known examples of life's resilience is the extinction of the dinosaurs. About 66 million years ago, a massive asteroid slammed into the Yucatan Peninsula, triggering catastrophic global consequences. The impact unleashed massive earthquakes, tsunamis, and wildfires. The impact also released enormous amounts of dust and debris into the atmosphere, blocking out the sun and causing a global cooling event. The dinosaurs, along with many other plant and animal species, were unable to survive this cataclysmic event. However, this extinction event also created opportunities for new life to evolve. Section 6. Cataclysm and Renewal. The extinction of the dinosaurs allowed mammals to thrive and diversify. Mammals, once small and nocturnal creatures, were able to exploit the ecological niches left vacant by the dinosaurs. Over millions of years, mammals evolved into the diverse array of species we see today, including us. The Earth's continents, once joined together in a supercontinent called Pangaea, continued to drift apart. This continental drift, driven by the movement of tectonic plates, shaped the Earth's geography and influenced the evolution of life. The formation of mountain ranges, the separation of continents, and the creation of new oceans all played a role in the evolution and distribution of life on Earth. Life, in turn, has also shaped the Earth. The oxygen we breathe, the soil beneath our feet, and the fossil fuels we rely on are all products of life. Life and Earth are inextricably linked, each shaping the other over billions of years. Section 7. The Age of Humans. We, Homo sapiens, are the latest arrivals on this epic journey. Our species emerged relatively recently, about 300,000 years ago in Africa. We are the product of billions of years of evolution, the inheritors of a legacy stretching back to the dawn of life. Humans possess a unique ability to shape our environment and influence the course of life on Earth. We have developed technologies that have transformed our world, but also pose significant challenges to the planet and its inhabitants. Our reliance on fossil fuels has led to a warming climate with potentially catastrophic consequences. We are witnessing rising sea levels, more extreme weather events, and the loss of biodiversity at an alarming rate. The choices we make today will determine the fate of countless species, including our own. We have a responsibility to act as stewards of our planet, to preserve the incredible diversity of life and ensure a habitable Earth for future generations. Section 8. Earth's Uncertain Future. The Earth, our home, is a dynamic and ever-changing planet. While we have witnessed remarkable changes throughout Earth's history, the future remains uncertain. The Earth's ultimate fate is intertwined with the life cycle of our Sun. Our Sun, a star like countless others in the cosmos, is about halfway through its lifespan. In about 5 billion years, the Sun will begin to run out of fuel. As it exhausts its hydrogen supply, it will expand into a red giant star, engulfing the inner planets, including Earth. Long before this fiery demise, however, the Earth will become increasingly uninhabitable. As the Sun expands, it will become increasingly luminous, causing the Earth's oceans to evaporate and its surface to become uninhabitable for most life forms. The Earth's fate serves as a reminder of the vastness of cosmic time and the transient nature of our existence. While our planet may have an expiration date, life itself is tenacious and may find a way to endure. Section 9. Our Cosmic Perspective. Understanding Earth's story, from its violent birth to its uncertain future, gives us a profound perspective on our place in the universe. We are part of something much greater than ourselves, a cosmic tapestry woven from stardust and shaped by the laws of physics. By studying Earth's history, we gain a deeper appreciation for the interconnectedness of all things. We see how life has shaped the planet and how the planet has shaped life. We recognize the importance of preserving the delicate balance of our biosphere. As we look to the future, let us carry with us the lessons learned from Earth's epic journey. Let us strive to be responsible stewards of our planet, protecting its biodiversity and ensuring a habitable future for all, for in the vastness of space, Earth is our only home.